Alright, so that was Jim Carrey in the movie of Bruce Almighty. So in the movie, he actually prayed to the Almighty God to give him superpowers, and God answered his prayers. Right, so he's able to perform superhuman stuff. Go and watch the movie. I shall not elaborate a little further. Right, but he's saying that I've got the power. And clearly, the power that we are going to discuss in this topic is not those kind of superpowers. Right? It has something to do with strength, sort of. When you think about someone being powerful, you think that someone has very high, is very powerful in the sense that he has a lot of strength, can carry heavy stuff and do a lot of work. Now, when you say work, yes, correct. That is the work that we're talking about. So, what does it mean by power and how to calculate it? We will see in this video. Let's get right into it. Hey guys, what's up? Welcome back to the classroom. It's Mr. Low, and today we're going to finish up the chapter Work, Energy, Power with the third part of this three-part lecture series on power. So just now if you see in the video, Jim Carrey, he possesses some form of godlike powers, right? And I was saying just now that when we talk about powers in layman terms, usually we refer to some superhuman strength, being able to carry heavy stuff that's very powerful, or for some people who are into superheroes and whatnot, they are superpowers, right? But in physics, we don't really mean, of course, we don't really mean superpower, but the idea of being able to carry heavy stuff, it's kind of related. So let's look at the definition itself, okay? Power is the rate of work done or the rate of energy converted. So you see the word rate two times, right? But what does it really mean, right? So rate has to do with time. So this rate here means you divide the quantity, divide by time. So for instance, if I say, okay, I'm eating 5 grapes every 1 second. Okay, that's not humanly possible. I'm eating 2 grapes every 1 second. What is the rate of me eating grapes? Well, if you're sharp, you will know that the answer is 2 grapes per second. So it's something to do with something per second because you're dividing it by time. Okay, so power is, in this case, is work done or energy converted per unit time. You divide the work done or energy converted by time. So you can see immediately in the formula itself, it's very clear here. Power equals to energy converted divided by time, or power equals to work done divided by time. So something is powerful if it can do a lot of work within the same period of time, or can convert a lot of energy, within the same amount of time. Just like as a student, you're a good student if, let's say, you can do a lot of work within 1 day. Right, of course that's not true, right? That's not how I judge a student, but you see the idea is there, right? Okay, so power is P represents power, of course, with the SI units of watts. Okay, it's a very interesting unit. Energy or work done. The E is the work done or energy converted. Okay, you can either have E energy or work done. Okay, depending on the case, depending on the question itself. Okay, you need to know which one to choose. Alright, so both, as you recall from the previous part of the video, both have units, SI units of joules, right? And time is in seconds, SI units. So if you look at the units of watts and joules, you can probably guess Newton. These names, these are family names. So if you are the one who so-called discovered or invented this unit or quantity, then congratulations, you get to leave your family name in history. Alright, so work hard and be scientists and make your ancestors proud. Okay, so simply said, power is about how fast something does work. Something does work or converts energy from one form to another. Recall the principle of conservation of energy. Principle of energy conservation. Okay, this one states that, energy cannot be created or destroyed, but can be converted from one form to another. And the part 2, remember the part 2? right? Total energy in a system, isolated system rather, remains constant, right? So if there is some form of energy conversion, then we can talk about power. Okay, so moving on, let's use one example to make it clear to you, to nail in the coffin. Right, so this one is about energy conversion. If you read the question, let's do it together. Okay, electrical heater converts 100 joules of electrical energy to 100 joules of heat energy within a time frame of 2 seconds. So from here you can very clearly see that this 100 joule of electrical energy to heat energy, that is the E, that's the energy conversion, right? And the time here is 2 seconds. All right, so what is the power of the heater? Okay, very clearly, right? So here you remember have to quote the formula itself. P equals to E over T. We know that the energy converted is 100 joules and the time taken is 2 seconds. Everything in SI units, so all is good. You can go in and plug the numbers, and the result 50 watts. W-A-T-T-S. Capital W, by the way, right? So for units, of course, you must remember that just like G, just like A, all the symbols that we use in physics, you must remember which ones are capital letter, which ones are small letter. Okay, so in this case, this example talks about energy conversion. Okay, later we will see some examples concerning work done. Yeah, conversion. Okay, so E over T. Okay, next one. This one is also energy conversion, but this time in this case is the gain in GPE. So let's look at the question here. Alice runs out a flight of stairs with 12 steps, okay, within a time of 10 seconds. Okay, each height is 0.1 meters tall. In case you have difficulty visualizing, so maybe you might want to draw some diagram here, and then each of this is 0.1 meters, and then there are like a total of 12 of them, right? 12 of them. So Alice has a mass of 45 kg. What is the power she generated during this run? Okay, so there's a lot of information here. Okay, there's the number of steps, there is the height of the steps, there is the time here, and Alice's mass. Oh my goodness, what do I do with it? Okay, so don't panic first. Let's look at what we are asked to solve. Yeah, we are asked to solve for the power. So let's first of all quote the formula. Of course, the way that I present here may not be the way that you think, because I already know what to do. But in case you are still a bit lost in the exam, this is how you can think. Alright, so we are asked for the power. So P equals to E over T, okay, or work done over time. Okay, so okay, of course you can write both down, work done over time. Okay, right. So let's see, are we going to talk about E here, or are we talking about work done? Just to let you know, actually you can do both, but I shall do E for this case. You can go back and figure out later how you can use work done to answer this question. Yeah, okay, so I shall choose P equals to E over T to answer this question. But first of all, what is the energy here? What is the energy we're talking about here? Clearly, if you're going to ascend up a flight of stairs, what energy are you going to gain? GPE, right? So from here, you have some height above ground, and therefore definitely you have GPE. So in this case, we can say that, okay, energy is the increase in GPE over here. Okay, so the E is gain in, or change in GPE. Yeah, the symbol triangle, remember, it represents change. Okay, this one is from chapter 2 kinematics. Alright, so doesn't matter, you can write in words, it doesn't matter. Okay, so change in GPE in this case, mgh, the height. Yeah, okay, so let's put in the numbers. What is Alice's mass? 45 kg. 45 times g over here is 10 multiplied by height. What is the total height Alice gained after running up the flight of stairs? 12 steps, each step is 0.1. So let's multiply them together. 12 steps of 0.1, that is 1.2. So 45, so it's 450 times 1.2 meters, so called, right? And so that gives you the number equals to 540 joules. But of course, we're not done yet, because we are tasked to find power, not energy. We have only obtained energy so far. So let's just put in the number into the formula. Alright, so back again, P equals to E over T. So we substitute in the number 540 over what's the time taken. Let's go back to the question. Within a matter of 10 seconds. So 540 over 10. It's a nice number. 54 watt. What is the unit? Watt. W-A-T-T. Pun intended, right? Okay. So there you go. Okay, using energy, P equals to E over T, you first have to identify what energy are we even talking about here, right? So running up a flight of stairs is, we are talking about GPE, of course. Okay, so first step is to go and calculate GPE, plug into the formula, right? So very importantly, why I asked you all to write down the formula right at the start. It's not just for the mark's sake, you see. It's really for you to know what you need to find out from the question, alright? So I hope that's clear enough for you. Okay, let's move on. This one is also about energy conversion, but this time round, let's read the question here. Okay, a kettle is rated at 1850 watts. First of all, if you have no idea what is this meaning of rated, okay, you will learn this in a later topic. It's called power rating. Okay, so let me just write it down over here for your reference. This rated here refers to power rating. Okay, every appliance, if you look at the label, the energy label behind, you will see a power rating. Okay, in this case, even if you don't know this is power rating, you look at the units, watts, you know that this hints that this is power. Okay, power, right? So this kettle has power output of 1850 watts. We are tasked to find the amount of thermal energy it can generate. Right, so this is E. Okay, it can generate in, what's the time? 1 hour. Oh, okay, so here you have to be careful, yeah, because for T we have to work in seconds. So here 1 hour, we must always remember to convert to seconds, and that is 3600 seconds. Okay, if you are not too sure, please go and revise how do you convert from hours to seconds. If not, you can ask in the comment section, or you can text me personally if you know me. Alright, so let's look at the formula itself. Okay, if you're just completely lost, let's write down the formula. P equals to E over T. Now what are we interested in finding here? We are clearly interested in finding the energy, right? Because it's the thermal energy. So in this case, E refers to the thermal energy. So if you are told to find E, question is, do we know the power? Yes, we do. It's right here. Do we know the time? Yes, right here, right? So everything is ready. We just have to do a little bit of algebra, massage the equation so-called, okay, and make E the subject. E equals to power times time. Now at this stage, you should be familiar with algebra, right? This is very basic algebra, cross multiplication, right? Simply cross the T up, okay? If you're not too sure, seek help from your math teacher or tutor. Oops. Alright, so E equals to P times T, and let's just put in the number 1850 multiplied by the time here, 3600. Okay, so if you press your calculator, you should get the answer of 666 and 4 zeros, 3 sixes and 4 zero, right? So I don't like to leave answer as such a big number. I like to always convert it into standard notation. So that's 6.66 times 10 to the power of 6 joules. Oh, so many sixes. Okay, so that's it. Okay, so in this question, we need to manipulate the algebra a little to make energy the subject, which is what we want to find. Alright, let's move on from here. Okay, another climbing of stairs. Okay, so this time round, I'm gonna show you how to work the question by considering work done and also considering by energy gained. By energy gain, the method by considering energy gain, we have already seen it just now. Over here, running up a flight of stairs, you just need to consider the GPE. Okay, so I'm gonna start with this first because that's what you're familiar with. Okay, let me just draw a line to separate the two methods here. Okay, so by energy method, let's take a look at the question first. Okay, Alice has a mass of 40 kg, M, while Bob has mass of 50 kg. Okay, so there are two different individuals at play here. One is heavier than the other. Okay, both run up a flight of stairs and they reach the top at a height of 5 meters above ground. So this time they already gave you the height. Okay, instead of having to, calculate each step is 0.1 meters. How high is the flight of stairs? Alright, they already tell you. Right, so Alice took the time of 8 seconds to do so, while Bob takes a little longer, 9 seconds. Question: who generates the greater power output? So again, you have to go and calculate the power, right? So it's a contest between the battle of gender, right? Battle of the sexes. Who is more powerful? Is it Bob or is it Alice? Right? Seems like Alice took a shorter time to run up the flight of stairs than Bob, but does it mean that she's more powerful? Let's take a look, okay? So, if we consider energy gain, so you know that we are calculating GP over here. P equals to E over T. In this case, the energy is the gravitational potential energy, GPE, which is E equals to mgh. So I'm just going to replace E with mgh over T, right? So, you should be familiar with the algebra. Let's not feel afraid of this. It's simply substituting. Okay, later we're just gonna substitute the numbers inside. Okay, so mass. Do we have the mass of the? Do we have the masses of the individuals? Yes, we do. Okay, 40 and 50 kg. G you already know it's 10, and the height is fixed at 5 meters. Alright, so let's go ahead and substitute the numbers. But first, we need to be clear of who we are talking about. Okay, so for Alice. So let's calculate for Alice first. P equals to mgh over time. Okay, in this case, the mass of Alice is 40 multiplied by 10 multiplied by 5 over time taken. How long did she take? 8 seconds. Okay, so here we can cancel, do your basic math, and then you've got 250 watts. Okay, so we will do so for Bob as well, and we'll see who wins, yeah? Okay, for Bob, P equals to mgh over time as well. Bob has mass of 50 kg. 50 times 10 times 5 over, how long did he take? 9 seconds. 9. Okay, at this point I need my calculator. It's approximately approximate to 278 watts. This is rounded off to 3 significant figures. So it's because it's 277.777777. Okay, so answer: who's more powerful in this case? Clearly Bob. Sorry. Okay, the guy wins. Alright, so even though he took a longer time to reach the top flight of stairs, but because he is significantly heavier, 10 kg, you realize that after calculations, Bob has a higher power output. So let's just write down the conclusion at the bottom, because the question asks for who has the greater power output, yeah? So I'm gonna write it down here between the two methods, because both methods should give you technically the same conclusion, right? So answer, therefore, Bob has the greater power output. Okay, please remember to answer the question, yeah? Okay, so we have worked through the energy method by considering energy gain. P equals to E over T. Now let's look at work done, right? Because I have not discussed how to work the question by considering work done. Okay, so let's write down the equation first. This time is work done over time. Now what is work done? Work done is simply force times distance over time. Our work done is force times distance, right? But power is force times distance over time. Okay, so at this point you need to ask yourself, what force are we talking about? Okay, what's the force we're talking about here? Let me shift the page a little bit, okay, to the diagram here. Okay, in order to climb up the stairs, first of all, we do know that everybody has a weight, W. Okay, it's weight W, right? So in order to climb stairs, to lift yourself up, to overcome your weight, you have to exert a force equal or at least equal or more than the weight. So in this case, let's just assume that the force is equal to the weight of the person so that the person can climb the stairs. Alright, so here we can simply replace force with weight. So this is equal to W times D over T. Okay, now this is weight. What is the formula for weight? Again, we need to substitute another formula. Okay, so since recall that W weight is equals to mg. Okay, hang there, the algebra is a little crazy. Okay, we will substitute the W equals to mg into the formula for power. Therefore, power equals to mg times distance over time. Okay, now because this distance here, next thing, let's consider what distance are we talking about here. Well, the distance here is the distance traveled upwards, isn't it? Which is equals to 5 meters, right? Because both of them ascended up the stairs. Okay, remember, it's the distance traveled in the direction of the force. So both of them exerted a force upwards, and the distance traveled upwards is 5 meters. And in fact, I should actually write down the parallel distance. Okay. All right. So in this case, we can simply replace distance with height equals to mg times h over t. All right. And if you know your algebra, it's simply mgh over t. I can skip the multiplication sign. Okay, so we've arrived at this formula, P equals to mgh over t, and then you should recall, that sounds familiar. Alright, because if you go back to the previous method by energy, you realize that, oh, actually, we're looking at the same thing. Okay, so you realize something, that work done, see this work done here, is later on becomes, this work done here later on becomes mgh. Do you realize that? Let me change the color. No. Work done later becomes mgh because it's weight times height, you see? So this should remind you of something else. Work, this is work done, and energy. What does this remind you of? Well, it should remind you of the previous concept that we learned in the energy part, which is called work energy theorem. Where is it? In the last topic here, work energy theorem. Now this work energy theorem, let's do a quick recap here. It tells us that when we do work done on an object, it then becomes, the work done later on becomes the energy gained by the object. Okay, so this is work energy theorem. We come back to here and we see that the exact concept comes in. When we consider the work done by Alice and Bob to lift themselves up, the flight of stairs, they gain GPE. So work done by them then becomes energy. In this case, because the work done is against gravity, the work done becomes gravitational potential energy, GH. Alright, I demonstrated this using a small object in the last video. You can take a look at that. So you realize that if I continue the working here, I should get back the same answers, okay, for Alice and Bob, because, well, we arrive at the very same formula, and hence, by both methods, the conclusion is the same. Bob has greater power output. Alright, so I know this is a little confusing, it's alright. Just go back and read again, but the idea here is, because work energy theorem, these two methods both work, they should be equal to each other. Alright, so that's it for this video. Okay, in this lesson, we learned about the idea of power. Okay, there are two meanings to power. One is energy converted, one is work done. Okay, both energy over time or work done over time. Okay, and the word here is rate. Okay, rate has to do with time, how fast something happens. Right, work done over time means how fast work is done. right? So we looked at a few examples where we use energy to calculate power, right? Like this kettle output, right? And this heater, right? We also look at a particular case whereby we use work done to calculate the power, and you realize very quickly that, oh, okay, it's kind of related to energy because of work energy theorem, right? So this is why right smack at the beginning, I said that they are equal, right? Power equals to work done or energy over time. So that is it, guys. That concludes the 3-part lecture series for the chapter work energy power, right? I hope you could understand what's going on because there's just a lot of formulas going around, right? So we have number 1, kinetic energy, half mv square. We have GPE, mgh. We have work done, force times parallel distance, and last but not least, power equals to work done over time or energy over time. So that's 4 different formulas for this topic. It's pretty huge, right? If you find yourself having difficulty understanding, please read through the examples and work through the examples again. Do not just read through and think that you understand. Please cover up the answers, read through the questions, make sure you get the presentation, make sure you get the steps right. Alright, if you have any concerns, please consult your teachers. If not, I'll see you in the next topic. Take care.